Okay. So let's get things started here. So, how's everybody? All good? Second week. Coming towards the end of second week. Okay? Again, if this is by any chance your first class with me, you should have a look at the videos that get recorded for each class. Okay? So today, what is it that we're going to be doing? Well, we have done our quiz already, quiz 1. Great. Out of the way. I'm going to be demonstrating exercise 2 that we started last class. So I only demonstrated 1. I'm going to demonstrate the second one today. So that will be the beginning of our class today. And then we're going to be talking about classes and objects. So today I will start with some lecturing of classes and objects. And then next week we're going to get hands-on. We're going to do exercises about classes and objects. Actually, I'll already be providing the exercises. So from now to next class, if you want to start put them together, that's fine. If not, that's fine. We can start next week as well. Okay? So let me just quickly jump to Instantiate. And let's, okay, I think this is, no, it's not, no. And we should have a look. Thank you. So if you have a look at week 1, we have the exercise there, the 2 exercises. I demonstrated the first one. I'm going to demonstrate the second one. Very simple, not a big deal, but I want to demonstrate that. So with Visual Studio, I will always be demonstrating using Visual Studio 2019. Okay? So 2017 is very similar. It's slightly different. The interface is slightly different when you are creating a new project, but you're going to find your way if you are using 17. I'll be using Visual Studio 2019. So I'm just going to click on Create a New Project. If you have done this before, you're going to have console app.NET Framework already available. If not, you can just type in console application. When you filter, make sure that you have C# and make sure that you have .NET Framework. Not .NET Core, but .NET Framework, okay? So let's select this one here. Next. And then for our exercise, write a program named TextMath. So I'm going to call the program that name, okay? So I'm going to say TextMath. And I'm going to add a 03 here because I have done this a few times. So there will be one already called TextMath there. So I'm just going to add 03 at the very end. Framework, you can keep whatever comes as default. And you hit Create. Then from here, don't change program. Don't touch that. You don't need to touch that. Don't make changes here to the main. Leave them as they are, okay? And then what else does it ask for? Okay, so include 2 overloaded methods. One that accepts a price and text rate as double, and the other one is price and text rate as an integer. So we're going to be doing overloading here. Okay. So how should we call this method? Okay. Let's say that we're going to call it calculate text. You could call it something else. I'm not going to dictate what name, unless the question states that creates a method with this name. Otherwise, you can use your own judgment there. What I'm going to be a stickler about is the casing. Okay? So, and for now, don't worry about what static means. We're going to get to know about static a little bit later today. So I'm going to say static. For now, I'm going to say void, but we're going to change that in a second. And the name of the method is calculate tax. Now we're going to have some parameters here. Two parameters, price and tax rate. So I'm going to do this. I'm going to say price is a double, so double price. And then we're going to have tax rate. So tax rate in the first case is a double as well. Okay, so let's go double. Let's call this tax rate. You see how I named tax rate? I named used camel casing. First letter of the first word, lowercase. The first letter of the following words, uppercase. Okay? So for that, I'm going to be a stickler. Name of the method, Pascal casing. First letter, capital. First letter after that, all capital. Okay? Also, try to use meaningful names. If we have a price, call it price or call it something similar. But just by looking at it, I can realize, oh, this is the price. If we put A there, you have to tell me more. What is the A? So you have to document that. So by using proper naming conventions and naming, some of the documentation of the comments are not so much necessary because the name will tell you what this is about. Okay? Okay, so we have one like this. Now, let's do this. Let's have our method, calculate tax, returning the actual tax amount. So we have price, we have tax. How do you calculate? It depends, isn't it? I mean, in this case here that we have this as a double, if I want 6%, I'm going to send 0.06. So how do I get the tax? Just multiply. So, as I said before, many different ways to solve this. I'm going to be demonstrating my way, which no right or wrong here. I'm looking for the methods overloading. That's the main thing. So I'm going to say double output equals to price times tax rate. Now, here's the thing. I want to make calculate tax a very simple method. It will only do the math and return it back the final result. I don't want calculate tax to worry about, okay, how am I going to present this to the user? Am I going to use console.write? I want this worry about how to present. I want it to be in the main. I want calculate tax very simple, just the math. Okay? So I'm going to do this. Instead of using void, what void means there?
It doesn't return any value.
It doesn't return any value. Let's return a double. Okay. So let's say that we're going to return output. That's it. So that's the first one. We're going to use this as a starting point for the second overloaded method. So I'm just going to copy and paste. And now, for the second one, it's already complained that there is one similar. By the way, don't be afraid of moving the mouse over the red line when you see it. It will tell you what's the problem. You just have to read and understand what the problem is, okay? So it's saying that there is already a method called calculate tax with the same parameters. Of course, we're going to change. What is the change that we're going to do here? The parameter. What exactly the parameter? Instead of double, we're going to be using an integer. Okay? Now, what will change in our calculation here? So, instead of sending 0.06 or 0.13, we're going to be sending 6, we're going to be sending 13. So, we just divide by the 100, okay? And that's about it. Now, whenever I ask you to do something like this, you have to demonstrate that this is working. How do you demonstrate that? Well, you demonstrate by calling them in the main method so that I can run the application, I can see the results right away. If you just do this, well, you are overloading, that's fine, but you are not demonstrating. I would have to code myself and call the methods to see if they are working, okay? So what I'm going to do is I'm going to say here double tax 01 equals to calculate tax, and I'm going to send the price, which in the example it shows 79.95, so I'm going to say 79.95, and then on the first method we're going to send 0.06, so here you go, or let's try with the 13% of HST, and then tax 2 we're going to send 13. Okay, so you are calling both of them, and now I need to output this. I need to write this to the console so we can see the results right away. So how do I write to the console?
Can you do a little bit down?
Yep,
Second method.
down to the second method. Okay, so let me just hide this a little bit more. Okay, so I'm going to say console dot write line, and I'm going to use this way of writing this. So tax 01, and I'm going to say this, and then tax 02, I'm going to say this. Anyone knows what is the name of this approach of using this?
String interpolation.
Interpolation, okay, string interpolation. So we can actually use the variable names inside of the string if we wrap them up around curly braces, okay? Let's give this a try. So control F5. Here we have. Now, this is the tax amount, okay? What if I want to show this in currency? Like two decimal points and then the dollar sign at the beginning. How would you recommend? So we could format this by doing something like this. See, capital or lowercase would work. And then we'll put this. Let's run it again. If this moves away. Yeah, so now you see it formatted, okay? Okay. Any questions? Again, as usual, Padlet is open here. If you have any questions, you can access Padlet. You can ask, raising your hand, go to Padlet. That's the address. Okay? Again, any questions? Okay, one of the things that I really want you to leave this course, not this class today, but this course in general, knowing is how to troubleshoot your codes, how to debug your codes. Because a coder that doesn't know how to debug is not a coder. Most of our time as coders, we spend fixing codes. Maybe our own codes, maybe somebody else's codes. So I don't want you to go to web application development next semester not knowing this, because there I'll be pissed with me today if I didn't teach you that well, okay? So I'm going to start showing this, and I'll be reinforcing these points a lot throughout the semester, okay? So who knows how to put a breakpoint? Anyone? What should I do? Yep.
Literally just click on the gray part.
Click on the gray bar. Let's say that I want to put a breakpoint on line 13. So should I click here? I'm clicking there.
The right. A bit to the right.
Here. Here. Yep. That's one. What is the other way? You can right-click in the line, right-click, go to breakpoints, and then insert breakpoints. Okay? How do you get rid of the breakpoints? Just click on the red dot. Now, I just show you how to put the breakpoints, but how can we use that? What is the use of that? Well, here's the thing. Let's say that I'm going to put a breakpoint here on line 14. Because when the application reaches that line, I want to check the value, just to have a look at the value of text 01. So, for that to work, don't press Ctrl F5, because Ctrl F5 will not run the application in debug mode. It will bypass that. So just click on Start or press F5, and then the code stops there. So it stops the application, goes back to the code. Now you have that yellow line showing where is the execution point. So the yellow line is the execution point. The line that is yellow right now did not execute yet. Okay? It's waiting for my next step, command. But now I can move the mouse over, text 01, and I can see the value. If I move over text 02, because the line didn't run yet, it doesn't show the value yet. Okay? But with that, again, you can stop the application and have a look how things are looking like. Are they looking like you expected? Yes or no? If yes, great. If no, okay. You start troubleshooting. How can I move to the next line in troubleshooting mode, in debug mode? F11. F11 is 1. You can go F10 as well. Who can tell me what is the difference between F11 and F10? What does that mean?
So if you're debugging, you want to go down, you would hit F11. If you want to go up, you would hit F10.
Yeah, so F10, let me see which one is which. F11 will step into. So if you have a method call, it will jump to that method like this. Let's try F11 here. So F11, you see, we jump now to the method. So I can see, okay, outputs, great, price, okay, tax rate, okay. So again, I can keep checking, and I can keep pressing F11. Okay, F10 would not go into the method. It would step over the method, okay? Again, I'm not expecting you to get out of here today being an expert in debugging, but at least, at the very least, if I tell you, put a breakpoint in line 13, you know how to put that bloody breakpoint, okay? What is that? Awesome. Okay. Okay, so that's about the program. That's about the exercise. By tomorrow, end of the day tomorrow, I'll provide all the source code of the exercises on Instantiate, okay? Again, any questions? Can we move forward? Okay, so we're gonna get that one. Okay, so there's a question coming up. Let's see. Marking scheme. Professor, in terms of marking, if my program does not look exactly like yours, but we arrive at the same solution, what happens? That's fine. It will never, I can guarantee you that it will never look like mine. Not because I'm better or worse. It's just because we don't have the same minds, okay? That's fine. However, I'm gonna check what the question is asking, and I'm gonna check if what you did fulfills the question, fulfills the exercise. If it does, that's fine if it's different. That's fine if for instance, oh, you know what? I decided to put the output, the right line inside the method call. That's okay. I was not explicit about that. What I asked is that make sure that you create overloads for those two. If you did that, you're good. I will not ask you, I will not assess your codes based on something that I did not ask explicitly. Now, here's the thing. I'm not going to ask explicitly to put the names of methods, the names of variables, the names of parameters using camel casing, using I'm not going to ask you explicitly that. I'm going to assume that you know that you have to do that because I'm telling you right now, do that. Okay? Okay? Awesome. Okay, let's close this. And let's start something new. Okay, classes and objects. Who can tell me or give me your point of view about classes and objects? What are they? What's your understanding about them? Anyone? Yes.
Classes, when we have to use some entity like behavior and characteristics of any entity, and for objects we have for every class we can make different objects, and each object will have that behavior and the characteristics of class, and if we change in any of the object, another object will not appear.
Okay, that's a good one. Very technical driven. Yep, that's good. Anybody else with let's say a high level understanding of objects and classes? If you compare to, let's say, the real world, let's call it the real world, outside of computer science, what would be a good comparison between, object is like this and classes are like that? Objects in real life, you can think about, it's like whatever, and classes are whatever else.
Classes is like, for example, employers or workers, and the object could be like a counter or some engineer or financial guys.
Okay. Anybody else? Yep.
Objects are in the class. Like we can say in this class we have this kind of objects. Like for say if I'm saying like in the electrical parts there are some objects. So class is like object is into the class. Maybe that's what I think.
Okay, objects are into the class. Okay, makes some sense. Okay, so here's how I like to compare, not so much compare, but to do a parallel between classes and objects and something in our real life. Not necessarily in our daily lives, but something that we can understand outside of computer science. Classes are like a blueprint. What is a blueprint of a house? What is a blueprint? It's a design, it's a template, it's how the house will be built, isn't it? How it will look like if it's more of architectural blueprints. And then we have the house. So we have the plan for the house, and we have the actual house, the actual building, the physical building, yeah? Physical. So classes are blueprints. They are the plan, what you are planning to create. And objects are the materialization of that plan. Okay? Objects are the concrete examples of that plan. Okay? That's really it. Objects are objects are like the building, and classes are like the plan for that building. Okay? So the plan, the final house, the final building, will follow those guidelines established in the plan. The objects will behave according to the guidelines that we planned when we planned our class. Okay? Great. So today the idea is we're going to figure out how we can create classes, how we can create objects from those classes, how we can initialize them. We're going to be maybe talking about properties if we have time, but let's see. We're going to be talking about public classes, internal classes, maybe private classes as well. This topic is covered on chapter 9 of the book. I'll keep reminding you that if you are advanced, if you know a lot about this already, you can jump to the book, you can go to the very last section of each chapter. You can find plenty of exercises to get you busy forever. Not forever, but for a good amount of time, okay? So again, and if you get stuck, come to me. We're going to have exercise during classes, and you can always ask me those more advanced questions, okay? But I will not, I can tell you for sure about that, I'll not be able to go through every single exercise with everyone in class, okay? So, chapter 9 is our topic of the day. Let me jump back. Let's see if it's still open. It's not. Let me open Visual Studio once again here. Okay, so when you create a new project, a new console application, by default, you're going to get one class already. You're going to get this class here called program, okay? So this is a special type of class. This is the application class, and you need that. Each application of yours will have that class by default, okay? So far, what we have done is we have created a few methods within that class. We have not created a new class yet, okay? But from now on, we're going to start to see how can we create our own classes, okay? So this program class that you get by default will always have a main method, which is the starting point of your code. You cannot have more than one class in the same project with a method called main, because then the compiler will get confused and it won't know where it should start from, okay? So just one class with a method called main. That becomes a starting point for the application, okay? Okay, so that's the first class that we came across. Now, we're going to see how we can create classes from scratch. I mentioned to you that you should not mess around with the name program. You should not, but you can, okay? If you are adventurous, you can. But just make sure that if you change this, change the name of the file as well, okay? I don't think it will break, but keep it consistent, okay? So we try to keep one class per file as well. Why am I saying that? Is because this example, this is an application class. It's a console app, but it's called create employee, not program. So it's the same thing. You can give another name, but you see it has a main method, which becomes the starting point of the application. Now, this class, which is the application, now is using not only integers, strings, doubles, but also something called employee. We have a new type here. We have a special type here. For our My Assistants, we have a new type called employee. And we have a new way, something new here as well. Well, literally we have new here. So, what is this? So, what does that mean? What is that doing? It's doing something about the object. So, what is this? Just this part here. Employee My Assistant, what is that? How is that called in general? I'm doing what? A variable. I'm declaring a variable. When it comes to more complex structures like objects, we don't necessarily call them variables, we call them objects. Variables, we keep them for integers, strings, doubles, but for objects, those more sophisticated types, we call them objects, okay? So here, employee My Assistant, up to here, I'm defining the object. I'm just defining, I'm declaring, okay? The second part, after equal, I'm doing what? I am creating it. I'm creating. I'm allocating memory for that object. Okay? So this new here, employee, this is called the constructor. It allocates memory for that object to have a place to store its data. Okay? So declaration and memory allocation after that. So we declare and we create. Objects work like that. We declare and we create them. We declare and we create. When I say create, you may see the word instantiate. Instantiate a new object is the same thing as create, yes.
What's the difference between instancing and using the constructor?
You mean using like this?
That's creating an instance, right?
Yes.
New employee. So what's the difference between creating a constructor and an instance? Are they separate?
Okay. So here's the thing. To be able to create an instance of a class, you need a constructor. So it's not that they are one thing, that they are related. They are necessary for each other. You can only create a new object if you have a constructor. And by the way, just by declaring a class, there's already a default constructor that is created behind the scenes. I don't want to talk too much about constructors right now, because we're going to be doing that in the next class. That's just our follow-up after today, okay? But yeah, so constructors like this are necessary to allocate memory for that new object, okay? So we declare my assistant is a type of employee, and then we call up, what is this? A method from my assistant, correct? So I should expect that when I check the code for employee, I should be able to see a welcome message method there. Okay? Let's have a look. Next slide. Okay, so here we have our class employee. Our class employee has, how do you call this? What is this? A variable. It's a variable, isn't it? Yeah, we can call that a variable. However, when it comes to classes, objects, we give that type of variable, we give variables a different name. We call variables, we call them fields. Okay? So, ID number is a field. It's a field of employee. Okay?
Why is it private? Private each. And next one goes public.
Okay, good question. Let's keep moving forward. We will talk in a second about private and public. What are they? Okay, so let's just talk a little bit about terminology here, a little bit more, okay? By the way, once you get hands-on with this, with all of this, things will get more clear. I don't believe in coding by watching, okay? I believe in coding by, well, coding, okay? So we may not be able to go coding today for that yet, but that will be the first thing we do in our next class. Okay, so again, going over the terminology once again. So this is a variable. However, variables in the context of classes, we call them fields. Have a question?
Yes. Could you please repeat how do you call those variables?
Fields. Fields, F-I-E-L-D. Like a database field, a column, like fields. Yep. Okay, so we call that fields, and there will be a slide that will show that. Then we have what? Again, we have a method. So method, we call them methods. Okay. Now, both of them, the combination of properties and methods, we call all of them together as members. So we have there two members of employee. Members can be properties, methods, can be, sorry, I didn't mention about properties yet. We're going to get there. They can be fields like ID number, they can be methods like welcome message, they can be properties as well. I'm going to touch base about properties a little bit later, but for now we're going to be only talking about fields and methods, okay? So those are members. Now, we ask a little bit, what is private and what is public here? What does it mean to be private?
More secure.
Okay, it's more secure. What is that? Can or cannot? Cannot. Okay, that's correct. So if we go back here to this example, I would not be able to say my assistant dot ID number because ID number is private. But I can say welcome message because welcome message is public. Okay? So private can only be used inside the class, just inside the class, on any method, but only inside. Public can be used inside and outside as well, okay? Inside and outside. There are more, and this is called private and public, this is called the access modifier. It's called an access modifier. Okay? We have public, we have private, we have protected as well. It's another type. For classes, we have something also called internal. So those are access modifiers. And again, we're gonna be looking at them as we go along. Will you review the questions from the quiz today? I'm gonna think about what I'm just looking at a question here. So what I'll be doing for the quiz, I'll be providing the answers, okay? So they will be added to the Instantiate, okay? So I'll not review question by question. If you have anything specific that you want to ask me, come forward, but I'll provide you with the answers, okay? Okay. Okay. So there we have. We spoke a little bit about private, public. We have fields, we have methods. As I said, that's fields. Fields is what we usually call variables, okay? And then we have states as well. State. What is a state? Let's see if this is, yeah, it's next slide here. Let's have a look at that. We have fields there. This is a field. And then the value of ID number is a state. To be quite honest, I don't use this term too much, but you may come across that during exercises. So state is the value that is stored in a field, in a variable, okay? It's the state of that. What is a string that is associated with that string variable? That's the state of that variable, okay? So I mentioned to you that this is a field, then we have a method, and here is what is the name of this? With this get and set, anyone? This is a property, okay? So I'm not gonna dive into property right away, but those are the three types of members that you're gonna be finding on classes. We have fields, we have methods, and we have properties, okay? Fields, methods, and properties. We're gonna have a few other ones like constructors, but we're gonna leave it for later. Let's do this exercise here. So can you load Nearpod, please? So Nearpod, this is a quick one just to match the keyword with the explanation about the keyword. So match session. Okay, have a look there. I'll give you 2 minutes. It's a simple one. Okay, I'm going to take a quick attendance here. Ahmed Ali. Al Ajlan. Yep, okay. Amin Patel. Brandon. Yep. Kao Huang. Clara. Dhruv. Hakesh. Gurneet. Ila Song. Ishan. Jasmine. Jennifer. Joanna Lu. Georgie Rojas. Yep. Joshua. Timbal. Joshua. Karina. Martin. Mary Christine. MD, hello. Mustafa. Nita. Nihal Kumar. Pawanpreet. Saima. Sagar Kumar. Shaminda. Shima. Sinran. Syed. Tanvi. Teresa. Tomoy. Tony Lin. Yonga, Jim. And Yusuf. If I did not call your name, let me know. Okay, let's get this done. Okay, oops. Names, let me hide the names. Okay, so what do we have here? Are the blueprints for creating objects? What do we have? Classes, blueprints, it's the plan, it's the map on how to create an object, okay? Are data components of a class? Fields. One thing that I did not highlight here when I was describing fields is that usually in object-oriented programming, we have private fields and public methods. I'll be saying this again and again. From a technical standpoint, there is no problem of having public or private fields, public or private methods. But usually, in object-oriented programming, data is private, and we expose the data via methods. I'll explain this better as we go along. Let's keep going here. So, are the actual values, data, stored? For instance, the student name is John. What is that? It's the data, it's the state, okay? The value is 10, 10.1. Are the actions that perform operations? We have methods, yep. And then, objects are instantiations of a class. Objects are instances of a class, okay? Okay. Let's go for 5 minutes break, and once we come back, we keep moving forward. 5 minutes. Yeah.
Remember, I coming for Friday next week, and I told me I remember you to check for my present.
Yes, yes. Okay, good.
And also for Monday, I didn't choose your classes, so can I come for tomorrow for next for just session 1?
For session 1, okay. Yes, I have one at. I'll give you the time in a
I
second.
know it's 6:30.
Is that 6? No, is that 6?
Yes.
It's not tomorrow. Tomorrow is 4:30. 4:30 to 8:30.
Oh yes, yes.
It's not. Yeah, it's not the very last one. It's 4:30 to 8:30.
Okay.
Yeah, you can just give me, just let me know so I can put your presence. So for today, so we are doing for that class, correct?
Yes, for
Okay, so
session 1.
okay, so let me go here. Okay, so this is 3, and then it was for Monday, for first day, correct?
For Wednesday, I Wednesday come to your class is for Monday.
Got it. So I'm gonna put this for
Monday
so.
and Thursday, 2 sessions in 1 day. I come in.
Okay.
So,
So again, what's your name? Again.
Shima. I'm so sorry you.
No problem. No problem. Oops. Okay.
Yes.
So this one, and then. So, come on. What am I missing here? I'm doing the search here. Come. Okay. What's last name?
M-O.
Oh, it's the page. Okay, so that's this. The other one, isn't it? I guess. Okay. Okay.
Thank you.
Just it.
And also, I submit my exercise.
Yep. The exercise.
Yeah.
This one. That's fine.
I'm so sorry.
That's okay. No, I mean I'll just ignore that. Okay.
Yes, thank you.
No problem.
Yeah, Professor, last Monday was the quiz one.
You missed a quiz.
Yeah, Monday. Because I went with my brother in the city corporation.
Okay.
Some business problem. So I was stuck over there.
So that's quiz.
First
Okay.
quiz, last Monday.
Okay. If you want to come, you see here tomorrow. I have 2 classes tomorrow. I will have quiz 1 on both classes.
What time?
The first one, let's see. The second one is 4:30, but again, it's 4:30 until 8:30.
4:30 class.
Yeah.
Database.
And then the first one is in the morning, 10:30 to 12:30.
What's the room number?
This one.
This one?
This one. Yeah. Okay. So yeah. So I'll be doing quiz 1 tomorrow for this class. Okay.
10:30 to 12:30.
Yes. Okay. Yes. 1 second. What's up?
So the requirement for assignment here, namespace use only lowercase for the case here. So I supposed to.
I'll leave lowercase, ignore namespace. I don't
This one doesn't make
I don't check
Oh.
namespace too much, but that's okay. That's okay. That's okay. Okay.
Actually, I'm new to Visual Studio.
Okay.
So I just want to know what this exactly means. With each exercise will be added to a solution as separate project. Like I have done 2 questions of the assignment.
Okay.
And they both have one in this folder, one in this folder. So
So can you open one of them? You have Visual Studio open here already, maybe. Okay, so you see, you have a solution here. The solution has a project. This is the project. So you have a solution and a project.
Okay.
In the same solution, you can have multiple projects. So if you right-click in the solution, you can say Add, and you can say New Project, New Project.
So
Or
I have done the second question, so I can go first.
not in the same project. Not in the same solution, correct?
Yeah,
Yeah.
I have.
So,
In
you
the
know,
workspace, I have two different folders. For
you know what? So zip them up all together and zip as one single zip file and upload all of them together.
So zip this folder or this solution.
You zip all the folders that you have created for the projects. Because again, ideally we have one solution, 3 projects. That's the ideal.
I can do that again. That's not a problem.
Okay.
So you just want me to go on this, add new project,
Yes.
and then work on that project for one question, and then add another project and the third question,
Yes.
and then give you this solution as a zip file.
Yeah, but again, it's not just a solution file. Zip the entire folder so everything comes together. Otherwise, just a little file will come in. Okay? Make sense? Okay? Yep.
We're not sure if we have understand correctly. We have understood. So exercise 3, it's in here. So
Maybe
basically,
put it here.
okay, thank you.
No problem.
We need to initialize, right? And does that mean that actually we need to ask from the user or put by our own?
You can ask the user either way. If I'm not clear, if I didn't clearly say ask the user, you can hard code or you can ask the user.
And then, so basically, this is what it means, that we should get two numbers and then just find the average. So basically, if these are just 2, divide by 2, and then display the. So
Yep.
this is what this method was,
Yeah.
right?
Can you flip back to the PDF? So I just want to confirm. So private void, write an app that contains functions which make graphical initialization numbers, and then you need to find. Yeah, that's it. So you need to return. So go back there to the question.
But it's void.
So and then you need to find the average, main, and print result. Yeah, I mean the only thing here is that you have to find the average in main. So
Not in this method?
no, this method is just to actually look at the name, initialize, just to initialize them. The main will be the one that will be calculating the average. So you just initialize them.
I see. So basically, in that case, got it. So we are creating just.
So by doing this, you are just initializing, and then you calculate the average over there in the main. Then you're gonna get out of them, both of them, and then you calculate there.
I see.
Okay?
I see. In that case, yes, I will need most likely to change, in that case, those two numbers, because if I initialize them here, or will it be fine if I use first this method, and then after that method I will use swap, and again initialize and average. But no, in that case I don't need again initialize. Actually, if we need to...
The method will initialize for you.
Yes.
The purpose of the method is to initialize. What was that?
It's hardware.
Static.
I need to change this laptop. It's really very old, but I'm backupping everything for now. Basically, but what if I switch those two methods, because it was A and B, so that first the user will enter the number 1, number 2, then it will
Again, they are not necessarily related to each other. Swap will do one thing, initialize will do something else. So, I mean, they are not related. Yeah, I mean, you don't need to separate them up. Maybe you want to separate the variables. You have variables here and there that they are not related to each other. They have different functions. They have different purposes. Okay?
All right. Thank you.
Okay, no problem. Okay, let's carry on here. Okay, so just keep going here. Let's just keep going. A little bit more of terminology of definition, okay? What is a class client? And to be quite honest, this terminology, I don't see that very often. But again, you may come across during exercise, so I might as well just give you a brief explanation. Class client is a class that uses other classes. That's it. So we have the create employee class, which is an application class, and it uses employee class. That's it. It's a client. So this class is a client of employee because it uses employee. That's what means to be a client class. Okay? To be quite honest, again, not a big deal of terminology here, but you may come across that during things. Now, this is a big deal. That's where I would like to focus a little bit. Instance method. What is an instance method? Instance method means that this method can only be called from an object, not from the class. There are some special types of methods in special things that we can call just by calling the class name. But instance, what is an instance? Let's just, it's a sample. Again, let's bring into codes. What is the instance?
Copy.
It's a copy. But, so we have class and we have, when we instantiate, what is this? My assistant. It's a variable, but in the case of object, it's an object, okay? So an instance is an object. So when we say instance method, it's a method that can only be called from the object. It cannot be called from the class. Yes? Inside employee? Yeah, so we can call these methods internally inside the employee class. Is that?
I was saying that if you create, for example, another method.
Here in this class?
Yeah, inside this.
Create employee.
Create employee.
Yeah, so if you create another method, okay?
And I would like to call the welcome message.
Okay, then you have to declare again, because here's the thing. This my assistant here, what is the scope of my assistant? What is the range? Where is it visible? So scope means where is it visible? It's only visible where? Where you declared it. Where did you declare my assistant? Inside main. So at this point, my assistant can only be accessed here inside. If you want to access from another method, you would have to move this to become a variable or a field or a member of create employee. Again, the way it is right now, if you create another method, you'd have to declare it again because they are not visible. But my point with instance method is that, again, I can call welcome message from my assistant. I can say my assistant dot welcome message, but I cannot call employee dot welcome message because welcome message is an instance method. It's a method that is only available to objects, not to the class. You're gonna eventually see why that matters because we have methods that are only available to the class and methods that are only available to the objects. Okay?
May I just ask you, where is this my assistant located?
Here. We declare it right here. See, we declared, how do we declare? Instead of?
The name? Or
The name is right here.
yes, but shouldn't it be employee's name?
Well, So can you imagine if Instantiate, for each new employee, we write a new line of code saying Ederson employee, and there's a coder there programming that will add each. So again, so it's not, so we don't declare the variable attached to the value that it will be inside. The value will come dynamically. The value, what is the name of the employee? Well, maybe let's ask the user to type in. But we don't hard code dynamic information, because that will come on the fly. And again, can you imagine a system that for each new employee you have to write a new line of code with the name of that employee? No. Okay? No problem. So another hand. You. Yep.
Yeah, so and then the employee, it's a method, right? Or it's a class? Or...
What is employee?
It's a class.
It's a class. Okay? So we have the definition. Let me see if it's here. So here we have class employee. Okay? Okay, let's talk a little bit about public and private here. Actually, public, private, and another one that we're going to be using for class level. So, in general, for classes, we're going to have, for now, we're going to be working with two types for classes. Classes can be internal, and classes can be public. This is a special type of class, which is only applicable to nested classes. Nested class is a class inside a class. Let's not go there yet. We're just getting to know classes. I don't want to put classes inside classes inside classes inside classes. So it is. It is. So let's forget for a second that we have nested classes. So for what we are doing, we only care about like main classes. We don't care about classes inside classes. So for that, we just have those two. They can be either internal or public. Not private, but internal or public. What does that mean? What does that mean to be internal? Let's have a look at this class here. There's no public here before class. There's just class. It means that it is, let's go back there. It is what? Internal, because internal is the default. So if a method does not have public, private, or protected, if it does not have, it goes to the most protected, to the most closed one. And between internal and public, the most closed one, the most restricted one, is internal. So if there's no keyword there, if there's no keyword right here, it means that this class is internal. But it begs the question, why does it matter? I mean, what's the difference between a public class and an internal class? Anyone? Public is less protected. Public is, yes. But why does that matter? I mean, what is the impact? I mean, what is the relevance of that? Anyone can tell me? The ones that are more experienced with coding? Internal and public. What's the difference? Why do they matter? Yes? The scope. The scope, good one. In relation to what? Let's unpack that a little bit more. Huh? In relation to the namespace. Getting there. So here is what is the difference. Let's say that you have project A and project B. Two different projects, okay? Two different pieces of code, two different applications. Do you know that you can put some code in one and you can share that code with the other one? You can actually that's what happens a lot with coding. We share libraries, we share codes, okay? We share them. Now, a class that is flagged as internal cannot be visible by the second. So we have project A, project B. If there's a class in project A that is flagged as internal, it cannot be visible on project B. However, if it's public, it can. That's it. Public can be visible to another assembly, to another application. Internal cannot. Internal can only be visible on that project. That's about it. That's what the difference is. To be quite honest, we're not going to be working a lot with multiple projects referring to each other. Not going to be doing that a lot. But that's the basic difference between internal and public.
And in practice, how often do you use internal public classes?
In practice, use them quite a lot. I mean, there might be, see, one of the principles of object-oriented programming is hiding complexity. Is you don't expose everything to everyone. What do I mean by expose everything to everyone? You don't expose every member, you don't expose every class, you don't expose everything to all other classes, you don't. Because then you are overloading too much, not overloading, sorry. You are increasing the complexity of your application. The different pieces of your application only need to see what is important to them. If something is not important, or if something needs to be private, don't expose them. So, going to your question, if there are classes that should not be used by another application, make them internal. Why should that be used? Well, because we have not designed this to be used by another application. We have designed this just to be used by this application. That's about it.
Make it as simple as possible.
Make it as simple as possible, yes. Avoid too much complexity. To be quite honest, we drive cars, and we don't care about, we care that we have gas, and we care to know where we fill the tank. But we don't care about the actual tank. We don't check if the how do we measure the gas level in your car, in a car? You don't put your finger there and say, okay, is it too deep? Is that, no? Okay, so let me see. You don't do that. You see that in the panel, okay? So, again, the car, in this example, is hiding this complexity for us, and it's giving another signal to measure that. That's what happens with object-oriented programming. We don't expose everything, because then it's too much. We just show enough, or give enough. We don't give too much, we just give whatever is necessary. Again, don't want to overload too much, but that's how this works. Okay. Okay, let's have a look here. Again, we are back to, yeah. Let's keep moving forward. Let's have a look at this video here from our BFF.
Let's look at creating a class. Suppose you run a house-sitting business and you decide to create a house-sitting contract class. You might decide that fields that you need, this is Joyce Farrell. Let's look at creating a class. Suppose you run a house-sitting business and you decide to create a house-sitting contract class. You might decide that fields that you need in the class are the client's name and the number of days that the contract extends. Suppose in another class you're writing a main method that declares a house-sitting contract object named con1. You might attempt to set con1 days field to 4. But when you try to send the 4 to the field, you can't get in because the data fields are private. They are not accessible by outside classes. Instead, what you might do is write a setDays method and make it public. The setDays method accepts a parameter, and if the number of days is greater than the maximum allowed, it forces days to maximum. Otherwise, it sets days to the number of days passed in. In the main method, you might say con1.setDays and pass in a value. The value can be passed into the method. It becomes num days within the method, and then it's assigned to days, which can get to the field. Because the setDays method and the field are in the same class, the days can be set by using the public method.
Just step back here for a second. Let's speak for a second about this. Isn't this too complicated? I mean, what if we just access days, isn't it? I mean, why not? I mean, we could just say, as you are saying, they could do that. I mean, if we have a look here, see, we could say just comp1 days equals to 4. Now, we cannot say that because of privates. But what if we make this public? Is that okay? Will it work? It would. So again, forget about private. Let's just put it public. If we make it public, that would work. Isn't it? Yes, but, again, whatever we can make it more complicated, we're going to make more complicated. No, I'm joking. There's a reason for that not being the best way to do it. Because in object-oriented programming, there is this concept, and she will mention that in a second, called data hiding. We protect the data. We hide the data. We don't expose the data directly. We put something between whoever is trying to use our data and the way we store or the way we give our data back. We don't give them directly, okay? We give them via, I'd call it a proxy, but the problem is that if you just expose days as public, you are opening it up for this class here to do whatever they want with days. My class here called house setting contract, which is the one that has days, lose control over those days. It cannot enforce any rules around those days. What if I don't want to accept, let's say, okay, I only accept contracts of at least 2 days long. Well, if we expose days directly, whoever is using this class will be able to set days to 1, to -1, because it's an integer. Integers can be negative as well. The point is that this guy here, this house setting contract class, loses control over what data can be stored there. It loses control of that because you are exposing the data completely. Now, by making it private, so it's the only one that has access, and creating methods that now I can get a value, and I can validate this value, and I can say, okay, I don't want to accept values that are less than 2. It can dictate those rules now. But if we expose the fields directly as public, it loses that ability to control that. So, in object-oriented programming, we have this concept of data hiding. Data gets protected behind private. Data is private, and then we access them via public methods. That's why it becomes a little bit more complicated the way she is describing, but let's have a look again here.
Because the data fields are private, they are not accessible by outside classes. Instead, what you might do is write a setDays method.
Now, look at this. Okay, we kept it private, but now we have a public setDays. Now we can, somebody outside can send the number of days, but now we're going to apply a bunch of rules. We're going to apply our rules. And by our, I mean this class's rules. We're going to enforce those rules, okay? We're going to say, if number of days is greater than max, which max is 7, make it 7. So if I try to send 14, it makes 7. Otherwise, yeah, set the number of days. So we are applying a business rule here, which, if we had exposed this directly as public, we would lose that capability. we can no longer control how that field, how that data gets manipulated. It's free, it becomes free for all. We'll lose control. So again, this becomes a little bit more complicated, yes. But there's a reason for that. Okay? It's because we want to apply rules, control over that field, that property. Okay? Okay, a few more questions here. Let me see. Okay, let me flip here 1 second. Because I just saw some questions, and before we finish the video, I want to address them. Okay, so the quiz is done. So are we going to upload the quiz questions on Centennial? Yes, I will. Okay? I will. Do we need to follow the naming conventions of files for bonus assignment submission files? Not so much. Not so much. I didn't impose anything about files there. Okay, so yeah, that's okay. There is no hard rule about filing. Difference between protected and private access modifier. Okay, that will become more clear once we get to inheritance. But let me tell this. Let me show a slide here and tell about that. Okay, so we have private and public here. We also have protected. Protected, I don't want to hammer on that right away, but private is the most closed one, the most protected one. Public is the most open one. Protected is right in the middle. It's not as close as private, but it's not as open as public. What does that mean? What is protected? Well, again, question goes to you. Who knows what is protected? If you have some experience with coding, any ideas, opinions about protected? Yes.
For the private variables, we cannot use it in another class. But for the protected variables, if any class is extending our class, then they can use the variables.
That's about it. So if any classes inherit from our class, the children can use that method, but not outside classes. Again, too early to cover that extensively. Once we get to know inheritance, we're going to see that, but that's the answer. So protected can only be accessed by the children of that class. Okay? Again, we are too early to cover that right now. Okay, so let's see if we can finish that video.
And make it public. The setDays method accepts a parameter, and if the number of days is greater than the maximum allowed, it forces days to maximum. Otherwise, it sets days to the number of days passed in. In the main method, you might say con1.setDays and pass in a value. The value can be passed into the method. It becomes num days within the method, and then it's assigned to days, which can get to the field. Because the setDays method and the field are in the same class, the days can be set by using the public method. Similarly, in the main method, you might decide you want to output con1 days. But con1 days cannot get out. It's private. Instead, you have to write a public method, perhaps named getDays. It's public, so it's accessible by an outside class, and it returns the number of days. So back in the main method, you might write con1.getDays. And now the days can be returned from the public method, and the program can use them. With most classes, you make your fields private. This concept is called data hiding. You control how you get to the fields through the use of public methods. Thanks for watching.
So I'm going to play this again, the last part, which is what I would like you to get your minds around that. Again, in object-oriented programming, usually we have public methods and private fields. Okay? We protect the data. We protect the data. We don't let the data leak. We protect them via things like this, a method to set and a method to get. There are more streamlined ways of doing this, and we're going to be using properties for that, but this will come in time. So I'm going to play just this last part again here.
With most classes, you make your fields private. This concept is called data hiding. You control how you get to the fields through the use of public methods.
That's
Thanks
it.
for watching.
Okay, yes.
Could you open the YouTube video again?
Okay.
And go to like the last piece.
Hi, this is Joyce.
So, do you want me to play it?
So, oh, the class, they're two different, right? Class house setting contract.
Well, yeah, this is a class and this is the main application. This is using this.
Are they in two different files?
It doesn't matter.
Okay.
They can be in different files, they can be in the same file. They are just two classes that they can see each other.
How is the public, how is the main class able to see the private?
Who's private here?
Oh, sorry, internal.
Internal, they are part of the same application. So internal is internal to the application. Anything inside the application can see that class. Internal matters when you have two applications. You have application 1, application 2. This is in the same application. Okay? Okay, any questions? Okay, so let's open Nearpods and let's do a quick quiz. So open Nearpods and quiz 1. Okay, so that's quiz 1. Okay. Okay, so here's the codes. Let me see how many. 4 questions. The code is WFAKR.
This concept is
Oops. Okay, let's give this a try. Okay, so an object is an instantiation of a class, an instance of a class, okay? Again, instantiation, instance, you're gonna hear those terms quite a lot. Let me see how we have done here. Okay, so a third. So again, I want to close the gap. I want to close the red gap, okay? Make sure that we close the red gap once we are done with the quiz. If you have questions, let me know as we go along. Okay, so a class header or class definition. What is a header? The header is where you have the name of the class. Okay, so it's the header, the definition. Can contain all of the following except what? So let's see A. Can it have an optional access modifier? Yes. What are the two possible ones that we know so far? Public and internal, not private, okay? So we don't, for what we have seen so far, we only saw public and internal, okay? So yes, we have access modifiers. The keyword class, yes, we have keyword class. And the keyword, the term class, like look, the keyword class, yes, we have, yep. An identifier, what is the identifier of the class? It's the name of the class, okay? So yes, again, identifier, you're gonna see that term used as well. Initial field values, we don't have that, okay? Okay, most fields in a class are created with the private, okay? Most. And here's the thing, is there any technical problem to make it public? No, there's no technical problem. You can make them public. But again, if you make them public or make them too much public, too many public, you are breaking the object-oriented standards or approach, okay? So, private. And then, most methods in a class are created with the public. Now, does that mean that we cannot have a private methods? No, we can have private methods. Maybe there is a method that is only relevant inside the class. That's fine, okay? No technical problem about that. Okay, great. So let me see what else we have here. Let me cover this with you. I mentioned, you have seen a few times the keyword static. Static. So let's put this in context of methods. So you either have static or non-static. Static has the keyword static. Non-static has a doesn't have any keywords. Okay? So static means it's a static method or static fields. And then without static is non-static or dynamic method, a non-static method. That's the one thing that I would like you to try to stick to your brains there. Static members belong to the class. Non-static members belong to the objects. If there's, and again, you can even write this down. This will most likely be in quizzes as well. I can tell you this. Static members belong to the class. Non-static belongs to the objects. It means that, for instance, in a class like account, that we have a static method and a non-static, to access this method, we can only say account.method name, get interest rate. So we can say account.getInterestRate. We don't need an object to be declared. However, if we want to access get balance, we're going to need an object. We have to declare something of type account, let's say my account. We have to declare, create it, and then we can have access to the balance. I like this example because of this. Let's say that we are dealing with a bank. A bank has a standard rate, a standard interest rate. It doesn't matter if it's your account or my account. I'm not saying that all banks work like that, but in our bank, they have a general interest rate. So, to get the interest rate, does it matter if I'm asking from your account or from my account? It doesn't matter. So I don't need an object. I can just ask account, get me the rate. I don't need an object. However, if we want to get the balance only makes sense if it's your balance, my balance, then we need an object for that. So for general information that is not object driven, we have static methods. And then for object specific ones, we have dynamic ones like it doesn't use static. Again, I get it, it's a lot already, but as we practice this next class, we will have a lot of hands-on, okay? I'm not even going to give a chance to ask questions here about static and non-static. Let's leave this as just an introduction for that. Okay, let's see. That's okay. Look at this, static and non-static. Look, get interest rates, we have to use just the name of the class, account. However, to get their balance, we have to declare, create, and then we can access the get balance from an object. But one we access from the class, another one we access from the object. And they cannot be accessible. I mean, you cannot get this here or get this here. See, it has to be either via the class or via an object. Okay, to wrap things up, I'm just going to mention 2 quick things, or 3. The due date for the assignment is next Friday, okay? 11:30 p.m. next Friday, not tomorrow, in a week. For next class, under week 2, there is a bonus 2, very similar to bonus 1. You're going to have an episode to go through. Now I'm specifying which episodes. The questions are the same. And then, in the second point, you're going to have a 5 minutes video of UML. This is about diagrams, okay? So you're going to have a look at that, and you're going to ask me 3 questions. If you don't have a question, fake it, okay? But again, fake it at least related to the topic, okay? Don't tell me about the weather. Okay, so that's bonus 2. Then under week 2, you also have exercises. So if you want to start those exercises at home, you can, but we're going to be practicing them next class, okay? Again, we still have 10 minutes, so if you want to get, I know that you're looking forward to some coding, so if you want to use the last 10 minutes to start your exercise, you can. Okay. But that's about exercise. Again, how many we have here? 4 exercises. So, yeah, they are involving the contents that we have gone through today, and we're going to continue them next class. That's it about for me. If you have questions, yes? Is it there?
Like, is it graded?
It was automatically graded.
This one, no, the last one.
Now?
Yeah.
I mean, we didn't do a quiz now. Oh, those quizzes are not graded. They are not graded, okay? The ones that we do on your pods, they are not graded, okay? Great, so again, if you want to stick around to ask me questions or to start the exercise, you can. If not, have a good weekend. I'll see you next week.